Okay, so the product rule states that if h of x is equal to f of x times g of x, then h prime of c is equal to f of c times g prime of c plus f prime of c times g of c. Okay? Which is the same as just y dash is equal to u v dash plus v u dash. Just like a bit more complicatedly written. Okay, so if we recall the definition of differentiable at c, it states that f prime of c is equal to limit as x approaches c of f of x minus f of c over x minus c exists by first principles. Okay, so for h of x, we can take h prime of x is simply equal to the limit of x approaches c, h of x minus h of c over x minus c. Okay? And if h of x is equal to f of x times g of x, h prime of x will become the limit as x approaches c of f of x times g of x minus f of c times g of c over x minus c. Okay? So then this will become, just going to put some brackets so it's a bit neater. This will become f of x times g of x. Now let's just subtract and add f of x times g of c. Okay, which is just the same as adding 0, so we can do this. Now I'll just subtract f of c times g of c on the end here. Okay, so this is exactly the same over x minus c. Okay, so now if we isolate f of x and g of x on either sides here, we'll get limit as x approaches c of f of x times g of x minus g of c, okay, over x minus c plus g of c times f of x minus f of c over x minus c, right? Okay, great. So now, if we expand this limit here, we'll get limit of f of x, g of x minus g of c, all in brackets, over x minus c, plus limit as x approaches c of g of c, f of x minus f of c, x minus c, right? And now simply if we take these limits, all the x's will become c's, and this will become f of c times g prime of c, okay? From this first principles definition, this will become g of x minus g of c over x minus c. This is just first principles, so f of c times g of prime of c plus g of c times f prime of c, which is what we wanted. Great.